First ride is a success. Unfortunately, the UMA grip kind of melted. Full speed! Maximum power! That works really well. That's probably the easiest e-bike I've ever put together. The title of this video is going to be solar powered bike that can go infinitely, but first I have to build the e-bike. So this is what I made up. We got a smooth straightaway here. We're going to test it to see how fast it goes and what kind of wattage it pulls. But first, a summary of the parts. We got a Sunny Sky X8030S KV100. Nobody cares what those numbers mean, but it's a brushless motor from a big drum. I used this because it was free and was laying around my shop. I want to do this project as cheap as possible. So we got a big lithium polymer battery. It's a 6-cell or 22.2 volt battery. Got a motor speed controller that's not working right at all for this. This thing has what's called a brake on it for like the drone. For drone performance, sometimes you have to slow down a motor to get to tip to one side. So what the speed controller will do will stop the motor. And that's not really good when it's on a big wheel like this, because the big wheel doesn't want to slow down, so it heats up. So I did this with the cable. When I hit the brake, the motor lets go. How's that for some fancy trash engineering? Also, I did this project in like 3 hours total time. So interesting thing here is going to be the solar panels, but that is coming up later. For now, watt meter test, because I want to see how fast this thing can go by itself with just the battery power. I have a feeling it's going to do pretty good. This is working really well. All right, let's get a little more juice. Man, this thing is fast. It's getting kind of dark. I can't really see this very well, but it consumed about 350 watts, and we got up to how fast, Sam?
16, 17 miles an hour.
That's actually really not bad. If this thing was doing that all day, we could really go somewhere, and it really should, because I'll be carrying 400 watts of panels. You should probably actually go build the trailer full of solar panels now. So let's go do that. It turns out these solar panels actually are pretty sturdy, so I'm actually gonna use the aluminum frames they have as the trailer base itself. I got these cool wheels off of Amazon. They're actually for like large scooters, so we're gonna use those. I'm also gonna make this thing kind of stackable in case I have to get through some tight areas. I actually can stack the solar panels on top of each other to pull it around with. Finishing up the rest of the trailer is really easy. I'm just gonna go ahead and make them their own separate trailers. So I would basically pull them along as like a sort of snake design. The solar panels are also going to be wired in series, because series is better than parallel because you can use thinner gauge wire, you just a higher voltage. So that should be pretty easy to deal with. Alright, attaching to the bike's pretty simple. I'm just going to make it like a simple trailer design. Then it's time to add the solar controller. And the snake trailer bike thing is done. Alright, now that we're all done with the panels, it's time to check these things out to make sure I wired them right and check the voltage. So let's plug the solar panels into this digital multimeter. And we get 63 volts, which is actually kind of expected. These are 12 volt panels. However, because they're under no load, they produce about 18 to 20 volts. I'm going to add this brushed motor here to simulate a load to see if I can get these values to change a little bit. And boy, do they change. This digital multimeter is not having a good time with this. Let me go find an analog multimeter and see if we can get a different result. And it looks like 60 volts, that's not really quite expected. Anyways, I'm gonna grab the shaft and put a load on this thing to see if we can get to fluctuate up. Yeah, it's definitely fluctuating. And this is kind of the reason why we still have the battery on the bike, because the solar panels will be fluctuating in voltage from when I go to shade and more sun. The battery will act as a regulator to keep the speed controller happy, because the speed controller is very sensitive and will explode if it receives stuff like this. So in short, we have a bike, we have a motor controller, and we have some solar panels, and we have a solar controller and a battery. The solar panels feed into the solar controller, and the solar controller feeds into the battery, and the battery feeds the ESC, which feeds the motor. Let's plug this doodad in and see what happens. Bets on if it's gonna explode, Dave?
50-50.
Sam?
No explosion, maybe some smoke.
So this is the meter that meters the power coming out of the panels, because I want to be able to accurately see what's going on here before we use it all inside the bike. Plugging in. 61.4 volts. That's open circuit. It'll really go down when I plug this in. So now we're going to plug it into the charge controller for the battery. This will be the new thing. Alright, so here we go. I have no idea what's going on because this thing, oh, there it goes. Now it's consuming power. Oh, 46 volts, 45, 13.1 watts. Yes, it's charging. It's definitely doing stuff. I can see that now. Okay, that's awesome. So that's nowhere near the 300 watts I wanted, but let's get this thing out into the sun. So look, it's now at 63 watts of power. We were cruising the other day ago really fast at around like 100 watts. So this is a nice cruise. All this stuff just means a bunch of numbers and jargon that nobody's gonna care about. But let's go to the bike path anyways and give this thing a real test. This is an awesome test. I think it works extremely well. I mean, we're not generating really any power out here in the shade. I looked at the back of the meter. It's only producing about 6 watts in this out of a 300 watt array. 6 watts is nothing. We're cruising at 88 watts right now. That concludes this test. I'm also probably going to raise the wheels too because this isn't working out very well. Time to actually test the solar bike. We got plenty of sunshine to get skin cancer. It also turns out my tires weren't inflated all the way, so I'm actually gonna get higher efficiency today. So more air in the tires, less rolling resistance equals less wattage used. So the range should be even better today. So let's pump it up and then we'll go test this piece of crap out. Solar energy! What I'm going to do is I'm going to plug the panels first. We're going to drive this thing around a little bit, take the voltage of the battery down, and then we're going to plug the panels back in and continue to drive and watch the voltage go back up to actually have a legit solar bike that's generating more power than it actually uses. Alright, so we're on the motor power and battery only. Right now I'm doing about 145 watts of power is what I'm consuming, and the battery is down to 22.1 volts. I'll take it down to 21.9-ish, and then we'll put on the electric and then watch it go back up, and I'll keep biking for free, basically. Alright, so we've biked a couple of miles. I brought the battery down from 22.4 volts to 22.1, so we're definitely consuming the battery, obviously because the panels are not plugged in. Now, let's swap over to solar power and keep going. I'm pretty sure it's going to definitely keep charging, but before we do that, let's see what kind of gas we're getting out of it, because I'm pretty sure the panels, even though we're not really at solar noontime, are still putting out quite a bit of power. So we got 60 volts so far. It's actually using 0 power because the controller right now is doing some things trying to calculate. There it goes. So now it's doing about 199 watts is what it's putting back into the battery right now. And even then, I don't really consume too much like that when I'm using the motor unless I'm going really fast. This actually kind of sucks because those are 100 watt panels and it's only doing 200 watts, but yet there's 3 of them. This is an interesting thing too. I'll put my hand over here and look at the power. Just covering one cell, 132 watts. Take my hand off. Boom, it shoots up to 200. That's kind of incredible. It's because they're wired in series too, by the way. Just much more resistance when you block a cell. That's how easy when you break one of these cells in these panels, they're pretty much not really useful after that. If we're doing a gentle slow cruise right now, I'm doing about 85 watts on the motor, and the panel's doing 187. And watch the shake. Boom, 65. We're down to 17 watts of power out of the panel. That's terrible. So the motor's sucking roughly about 107 watts. I'm at a slow cruise right now too, so I guess this is working out pretty good. We're slightly going uphill too. I'm gonna get a little more gas. You know, one thing that sucks about driving this thing is that you get shade on the panels, and when you get shade on the panels, it doesn't produce any power. But there's also one benefit of having it move around: airflow. When solar panels get kind of hot, they become less efficient and produce less power, so blowing air over it, such as pulling it around a little trailer thing, cools it off, so it actually makes it more powerful. So it's kind of a catch-22. You get shade, but you also get more airflow. It's the end of the line, so let's see the backpack ends. We also have gone 8 miles too, because according to that sign right there, we started off in a town called Xenia, and we're now in Cedarville. Okay, I've never been here before. Anyways, yeah, 8 miles on solar, and it's kind of hot out here. Let's see what our battery's at. Oh, would you look at that? 23.5 volts. We've gone a whole volt and a half up. I know it doesn't seem like much, that's because that is a very large battery. So we've been biking pretty successfully, and I have not used any of the battery up. Pretty much all the sunlight went into the motor and then into the battery because it charges the battery up. Our solar meter thing right here says 23.7, but over here on the watt meter side, I think this is more calibrated correctly. It says 24.2, and well, that battery would be fully charged by now, or very close to fully charged. So that thing definitely works. Solar powered snake bike is definitely a success. I guess that's the end of the video. There's really not much more to do with it. And then it just keeps going. Let me know if you want to see me solar powered next. Oh yeah, be sure to check out Audible for sponsoring this video. And yeah, that was pretty fun.